Almost engineers. How are you?
We are fine, thanks. How are you, sir?
Sharp, thank you. Yesterday we left off somewhere. We didn't touch something, so we had to revisit it. Resistors in series. We said if you have this resistor connected in series with this one, connected in series with this one, connected in series with this one, and then here you're gonna have our ground there. Then here we have our supply. Positive 5 volt. Let me just give them values. Say here we have 560 ohm, 1 kilo ohm, and then we can just say 2.2 kilo ohm in this order. Remember that we said the current in a serial circuit stays the same, ne? Even if we were to add another resistor after this one, the current will drop, but it will drop even for all or throughout this circuit, ne? Meaning not like each resistor will have its own current. This whole circuit will have the same current. So now to measure the current, we'll have to break the circuit, ne? For the drawing, this is the symbol for the emitter, ne? If you see this symbol, it means that this is an emitter connected in series with the circuit. But now in a practical world, that's how you're going to do it. Okay, let's say this is your multimeter, this is your display, this is the rotary switch, this is your emitter, this is your probes. Yeah, this is your common must come here. Then on a probe, you must be careful that the probe you inserted where it indicated amps with the letter A. Then you have to move your probe to that socket, and then it must come to this point where the high potential of voltage come from, ne? And the common must go on the low potential part of the circuit. Okay, and then you have to select amps on the rotary using a rotary switch. Then it will indicate, let's say 1 amp. It will indicate there on the display the amount of amp that runs through the circuit. It's easy as pie, ne? Now let me show you how that done. Now let's assume you are using this multimeter to measure current in a circuit. So you will have to remove this red probe and then you put it in the amp rating. If you know the amount of amp that you're going to measure, then you can put it here by milliamps if it's a small amount. But if you don't know or it's a greater amount, it's always advisable to put it in a larger amount in order not to burn your equipment. After that, you will then select amps using this rotary switch. After that, they will then break the circuit and put the probes where you broke the circuit. Normally the red probe goes to the high potential side of the voltage, and then the black probe go to the low potential side of the voltage. Here you will then see your amp rating of the circuit. That's how it's done. Now some of the multimeter, like this entry-level multimeter, the socket for amps, ohms, voltage is the same. So you don't have to remove the probe unless you want to measure a little higher current. Then you can move it from the milliamps to amp rating. And you need to be careful. The maximum amp this one can measure is 10 amps. So if you go above 10 amps, you might damage your meter. You will then select the type of amps you want to measure. This entry-level multimeter only measures direct current. Basically, this is what you need to know if you need to measure a current in a circuit. In a series circuit, there's no specific point where you can break your circuit. You can break it here, you're still gonna get the same reading. Or you can break it even here, you can still get the same reading. It is the same as throughout the circuit. And to get the voltage, okay, before you go to the voltage, the reason why you have to break the circuit and put the multimeter like this is that electrons flow most through wire, through resistor. So even when you get there by the multimeter, it will flow through this probe into the multimeter and then come out this wire again to this resistor. It's more like that pipe inside water mass. If you need to know the amount of water flowing in this pipe, you will have to break this pipe somewhere here, for example, and then we have to put water meter something like this, and then we will get the exact pressure through this pipe. The same thing applies with the series circuit. We cannot measure current across or measure the amount of water flowing through the pipe across the pipe. You have to measure through the pipe. Now let's move over to voltage. How do we measure voltage in a series circuit for each resistor? Now resistors in series, they must divide voltage. So now to measure voltage for each resistor, you have to connect voltmeter across the resistor like this. This is a symbol for the voltmeter. If you connect a voltmeter like this across this resistor, you will only get the voltage for this specific resistor, not the entire series circuit. Let's assume the voltage across this resistor is 1 volt. Now to get the voltage for this resistor, you'll have to move the probes now from this resistor or from across this resistor to this resistor. Now let me draw the actual multimeter. This is the display, the rotary switch, this is a socket for the probes. Now the positive probe will be across this. And the negative probe come this side. So now your probe must select a V that indicates the voltage. Let's assume maybe the voltage across this resistor is 1.5 volt. You see 1.5 on the display. That's how you measure your voltage. The same applies with the voltage. If you don't know the voltage across the resistor, it is always advisable to select the highest voltage value on the rotary switch. If you do know, then you can select the appropriate voltage gauge on the meter. Now to know the voltage across this one, you do the same. You have to move this multimeter, these probes from here to this part of the this part of the resistor. Now let's assume the voltage here is 2.5 volt. Now if you sum up this voltage, they should give you the supply voltage, or maybe close to, let's say maybe they give you 4.8 volt instead of 5 volt. That means some of the voltage got dissipated in a form of heat. It's a normally loss in electronics. Now the reason why we measure voltage across instead of series, just like in an ammeter, is because now we are measuring the voltage drop or the pressure that is caused by this resistor against the push or the voltage source. Now let's assume this is our pipe. This is the water flow. So now in order to find the pressure that is applied or the opposing pressure that I apply when I press with my thumb here, we'll have to know the pressure, the input pressure, which is V1 in this case, or in case of voltage, and the output pressure, which is V2. That is why in order to know the pressure that I apply when I press down with my thumb on the water pipe, you will have to know the difference between these two pressures. The same applies here. You cannot measure the pressure inside the pipe, but you can always measure the pressure across. You can always measure the pressure across the pipe where we applied our pressure or our opposing pressure. Now let's assume that you don't know the value of these resistors. The resistor value is not always exact, especially on the operating circuit. Here, as it is 560 ohms, you don't know, there might be other components connected to this 560 ohm resistor. Components like a capacitor or other electronic components. Then they will affect the value of this resistor. So the best thing to do is to disconnect the resistor from the circuit. The best thing to do is to disconnect this resistor from the circuit and then measure the separate. Only then you can get the accurate value of this resistor, should you need to know the value of this resistor. In this case, okay, let me draw a multimeter. This is a display rotary. Now for ohms, you select most this sign for ohms. Let's say maybe it's here. It's ohms. Normally it goes together with the voltage probe. So this will be your black probe. This will be your red probe. It will give you a value 560. There's no particular way that this probe should be like. Either way, you can just connect the probe, you'll get the right value. Back to the voltage. On the voltage side, should you connect the probe the wrong way around, you'll see a negative sign in front of the voltage value. You must just know that you connected your probes the wrong way around. So what you need to do, you just need to swap them and the negative will disappear. Now let's conclude how we measure voltage, current, and the resistor in a series circuit. Now let's move to parallel circuit. Now this is how the parallel circuit looks like. .560 ohm, 1 kilo ohm, 2.2 kilo ohm. Now your supplier will be like this. 5 volt. Positive probe, negative, positive terminal and the negative terminal. Now in this case, our voltage, as you can see, it is across most. So our voltage will be the same throughout the circuit. Let me just draw this one with the red color. This one can stay black. As you can see, our positive 5 volt on this side will be present throughout this wire, and our negative here as well. So here we'll get positive 5 volt, positive 5 volt, and positive 5 volt. For the parallel circuit, the voltage is the same across. For the series circuit, the current is the same throughout the circuit. So now let's say we want to measure current in the circuit. So our current will must branch here to this direction. Some will continue and then branch again. Some will continue and then turn here, and then they will rejoin on this side. Now if we need to measure current here, we'll have to measure current for each resistor because current will differ. So we'll have I1, I2, I3. So now to know the current that's flowing through each resistor, we'll have to break the circuit either here or this side, it doesn't matter. Let's just assume this circuit gives 1 amp. So here, the greater the resistor, the lesser the current flowing through it. So this will be our ammeter. And then here as well, we have to break the circuit here, put our ammeter here, and then and so on and so forth. Each line will give us different current value. So maybe let's say here we are getting 100 milliamps, and then here we are getting, let's say 400 milliamps, and then here we are getting 500 milliamps. So the way we measure current is still the same. We'll have to break the circuit and then adjust our probes accordingly. On the rotary switch, we have to select where there is A, and then we select the maximum rating, and then we can now connect our probes here and here as well. Then we'll get the value of the current flowing through this resistor. For voltage, we can either know the source voltage or you can just put your probes across. The voltage will be the same for all the resistor. Now to know the value of a resistor, the same still applies as we saw on the serial circuit. We'll have to remove this resistor just like this and connect our multimeter like this. We'll then get the value of this resistor. If you measure this resistor while it's connected in a circuit like this, you will get the value. You get the wrong value. Maybe you might end up reading all these resistors connected in parallel. So it's always very much important to remove the resistor from the circuit before you can attempt to measure the value of a resistor in a circuit. Now let's go and see the practical part of these circuits. Now this is how a practical series circuit will look like now. I tune my supply to 5 volt at 1 amp. Here I have 4 resistors that are connected in series. It's 1 ohm, 1 kilo ohm, 2.2 kilo ohm, and 560 ohm. Here we will determine the voltage across each resistor, the current through the circuit, and the value of each resistor. Let's start with the voltage. I'll leave my probes like this and then tune my voltage, my multimeter to voltage, to the DC voltage. Now let's check the voltage across 100 ohm resistor. You see it gives me a negative. That means my probe are swapped the wrong way around. Now they are corrected. I'm getting 0.129 volt, 130. Let me move over to the next one. You see that each resistor has its own voltage value. I'm getting 1.32223. It's climbing. It's 2.844 on this side. It's 0.734 volt. These voltages, if you add them together, they will all give you the supply voltage, which is 5 volt. Let me confirm the voltage supply. It's 5 volt. Now let's move to the current. Now I'll measure current. Then I'll remove this probe from this socket to the current socket and then select the amps. I will then break the circuit. Now that my circuit is broken, I can now measure current. I'm getting 1.31 milliamps. It fluctuates between 1.30 and 1.31 milliamps. Then let me reconnect the circuit and break it somewhere else and see if I'll get the same value. Like I said, I'm gonna break it here. Can you see that the current stays the same no matter where I break the circuit? Break it again this side, just to confirm that the current stays the same. Indeed, the current stays the same in a series circuit. But now, for safety's sake, before you can do all these things, the breaking and the measuring, you need to make sure that first you switch off the circuit, or you switch off power through the circuit, then you break the circuit, reconnect your power or restore your power, and then you can measure. Do not break and reconnect the circuit while the power is still on. It is very dangerous. Now let's move over to the resistor. I'll let you restore the probes to its own original socket and then select ohms. First, I said you need to remove the resistor from the circuit before you can measure the resistance value, because if you measure it while it's in a circuit, it will give us a wrong value. Now it says it's 1.515 mega ohm. Now let me remove the resistor. Now let me measure it on the outside. Now it gives me 98.8 ohms, which is approximately 100 ohms if we take the tolerance into account, which makes sense now. Let's try this 1 kilo ohm. Now I'm getting 1.003 kilo ohm, which makes sense. Let me take it back to the circuit and measure it while it's in the circuit. You see, it gives me overload in the circuit, which is wrong. Now remember that if you measure resistor, you need to remove it from the circuit so that you can get a correct value. Now let's confirm that the total resistance of the resistance series is greater than the greatest resistor. First I'll have to remove the power and then tune my meter back to ohms. I'm getting 3.811 kilo ohm, and the biggest resistance in the circuit is 2.2 kilo ohm. Indeed, the total resistance of a resistor in series is greater than the greatest resistor. Now let's move over to the parallel circuit. Now this is what the resistors in parallel look like. I had to drop the voltage from 5 volt to 2 volt since the resistor started smoking. Since they are connected in parallel, the total resistance of a resistor dropped below 100 ohms, so the 5 volt was too much. I had to drop it to 2 volt for this demonstration. First, we start by measuring the voltage across each resistor to confirm that it will stay the same. I'm getting 2 volt. 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 Indeed, the voltage stays the same. Now let's measure current. Now let me break this circuit. I'm getting 3.61 milliamp flowing through 560 ohm resistor. I restore the resistor. Getting 0.93 milliamps. The bigger the resistor, the lesser the current. I remove this one. You can see already that the current doesn't stay the same. It varies with different resistors. Here I'm getting 2 milliamps on a dot. Here I'm getting 19.92 milliamps. You can see that the current it doesn't stay the same for resistors connected in parallel. Now let me measure the total resistance. I'll have to disconnect the power from the circuit complete. I'll remove the probes. Select ohms. The total resistance have dropped to 74.7 ohms.